Today we're looking at data handling and interpretation of graphs. And the first one we have here is mean, stroke, average. These two words mean the same thing. Mean may mean average. It sounds very interesting. So note, mean stroke average is the uniform distribution of any given data. Here there is no grade. We have to share everything that has been given equally. Now, like in my hands, I have 12 straws. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So, if we say that someone took 4 straws, another one was given 2, and then someone else has 6, that is not being fair. So what do we do? So if someone here got 6, another one 4, another one 2, we have to share these straws equally. We say, we reduce this person here. If we reduce here by 1, we shall have 5. If we added that one here, we shall have 4 here, and then this side 3. But still, there's some kind of grade there. So this one we have to reduce again. If we reduce 1, we shall have 4 here. This one 4. If we add that one here, and then everyone has 4. So that is the uniform distribution of the given data. So here we have to share things equally. Now, what's the formula for finding mean stroke average? The formula is sum of data out of number of items. Number of items in this case may mean like in this case, how many children were they given these straws? They were 3. Now here I'll write there 3, and sum would be 12. But let's look at this example here. Find a mean. I say that another word that we can use to mean mean is average of 6, 4, 0, and 2. Don't say that 0 is nothing. 0 is very important in this case. There is someone who received 0. So now we have our solution. We said mean. The formula is sum of data out of number of items. Sum means the answer you get after adding. So we shall come here and say we have 6 plus 4 plus 0 plus the 2. Don't forget there is a 2 there. Out of how many items are we adding? We are adding 1, 2, 3, 4. We are adding 4 items. Now, what is 6 plus 4? 1, 2, 3, 4, 5, 6. We have 6 here. Plus 4. 1, 2, 3, 4. When I put them together, I'll be having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 0, it will remain 10. And then plus 2, 1, 2. So this is 10 plus 2, 11, 12. So we have 12 divided by 4, which will give us, yes, it will give us a 3. So 12 divided by 4 is 3. So the mean of 6, 4, 0, and 2 is 3. So therefore, our mean there for that case is 3. And now we have to look at another item here that is called range. Range. Remember when we used to run, we would say, the other one has given him a very big range. Yes. So range means biggest value minus smallest minus the smallest value. It will remain the same. You may be having BV minus SV or HV minus LV. So that is highest value minus lowest value, or biggest value minus smallest value, or biggest number minus smallest number. For example here, find a range of 2, 1, 8, 4, and 9. Some of you have a tendency of reaching here and you stop there. But now, there is this other digit which has been put this side, this other value. So now, we shall come and say range equals to highest value minus lowest value. Our range will give us the highest value in this case Is it 2? No. 1? No. 8? Yeah, I think it looks. But we have a 9. And 9 is bigger than 8, so our biggest value or highest value is 9. Minus the smallest, which is 1. And 9 take away 1, we shall have 8. Finding scale. We're now going to see how we can find scale on pictographs, or when we've been given pictures, and then we see how we can go about it. So note, scale helps us to know the measure of the pictures given, how many items are in each picture, or how many items are each picture representing. For example, here we have pictures of pencils, and there are only 4 pictures. But now, according to this one here, is reading these 4 pencils, these 4 pictures are representing 40 pencils. Find a scale, and we've been told us the scale helps us to know the measure of the pictures given, how much do they weigh. So now here we are going to say the solution, scale is equal to total number. The total number now given is this one here, out of the number of pictures that we've been given. So now when we put our total number, which is 40, up, and we say out of how many pictures are here? 1, 2, 3, 4 pictures. So we shall say it is 40 divided by 4. And now here, 40 divided by 4 gives us 10. Because 10 times 4, we get back to 40. So 10 pencils. This one should mean that every picture of a pencil that you see here is being represented by, is representing 10 pencils. So that's why I have concluded here and said, therefore, one picture of a pencil represents 10 pencils. So whenever you've been told to find the scale or how many pencils or how many mangoes are being represented by one picture, get the total number out of the number of pictures you've been given. So you'll be able to find the scale. Now let's look at finding scale on a histogram and a bar graph. I've already told you that we can as well represent data, we can represent information on so many different graphs. One is a histogram, a bar graph, a line graph, pie charts, which we refer to as circle graphs, and others. So for example, here we have find the vertical scale. I told you that for a histogram, we don't need to get the scale of the horizontal axis, but we just need to get the scale of the vertical axis here. So find the vertical scale on the histogram. So now we've been told that scale helps us to know the measure of the pictures given. But in this case now, these are not pictures, but it's a graph. It's a graph. We call it a histogram because the bars are joined. When you look at the bar graph, the bars will not be joined. So this is what we call a bar graph. So now, here we have a histogram. We have John, Jude, Joy, Jane. And this side here on the vertical axis, we have number of flowers. It's like these people either were selling or picking or doing something connected to flowers, maybe an activity like selling and all that. So finding the scale on the vertical axis, we shall come here and say scale equals to range. Range, remember I told you is the highest value minus the lowest value, out of number of units remaining. Units remaining where? On that bar which has the least number of items. For example, here, what's the range? It is the highest, which is 48, minus the lowest, which is 24. So the highest is 48 minus 24. Out of, where does the 3 come from? 3 is coming from how many units are on that bar which has the least. It is 1, 2, 3. So we divide by 3. So 48 minus 24. 48 minus 24. What's 8? Take away 4. Good is 4. And then 4 take away 2. We shall have a 2. So 24 out of 3. When you divide 24 by 3, you shall get 8. Because 8 times 3 gets us back to 24. So our scale on this histogram is one small unit. The smaller unit is this one here. Each smaller unit you are seeing is representing 8 flowers. So when you have 8, like here we have 8 flowers. When you add 8 plus 8 is 16 plus 8, 24, and 24 plus 8 we get 32. So meaning John has 48 flowers. So now, if we have another example here where I've not written anything, and we say we want to find a scale, I told you scale equals to range out of number of units remaining. So what is the highest here is 20. 20, take away what's the smallest? The smallest I'm seeing is 10. Take away 10. Out of how many units are there on the smallest? It is 1, 2. So we have 2. So 20 minus 10, we shall get 10 divided by 2, and the answer is 5. So this one means that every small unit is having 5, or is representing 5 flowers. So if you write 5, 5, 5, 5, 5, 5, 5, 5, 5. Even if you came here and added here, 5 plus 5 is 10, plus 5, 15. When you write here 15, even here it is 15. If you say 5 plus 5 is 10, 10, 10, meaning our scale is right. So you just get the range, meaning the highest minus the lowest, and then you count how many units are there on the smallest. If there are 2, write there 2 and then divide. So now we look at another example of a graph, which we refer to as a line graph. And this one, as the name suggests, we look at lines basically. And we have an example here. The line graph below shows the temperature recorded in 5 days. And this side is temperature, which was recorded in degrees Celsius, times we say centigrade. And down here we have days of the week. Now for this line graph, you should be very careful. Here is not, Monday is not here in the middle, or Tuesday here, or here, and then like that. But the lines, that's where we have the days that we use when we're recording the temperature. So Monday, you say the recordings of Monday are here. Don't say that, Monday there was 0 degrees centigrade. No. This is, we are starting with 34 degrees. And on Tuesday we look for that star, it's here. And now we don't know what is there. Wednesday is also there. It's also not having a number. Thursday, yeah, this one Thursday has 40. I told you can also write those amounts on everything. And then Friday, yes, 38. So we have those ones which don't have. So we come here and say 34, but this is 36. There's one gap here, so we can as well say, what is between 34 and 36? That is 35. 34, 35, 36, now 38. So what is between there? Good, that is 37. And then 38, 40. So here it's 39, 40, 41, 42. But don't come on this one and say 0, 5, 6, 10. This one is not like that. So this one is counting in 5s. This one was counting in 8s. And this is counting in 2s. So now here we have some questions. But before we go to the questions, I say Monday, 34. Tuesday, what is there? This is 39. How about Wednesday? It is 42. I've told you that this one will help you when you've been given a question here to easily identify, because you may come here and again say Wednesday and you put 40, but this one just know is 42 because we've already written it there. So on which day was the highest temperature recorded? The highest, when it was very hot. I think here when you look at our line graph, you see the line graph. These are the items, the features that make it to be referred to as a line graph. So on which day was that? Yeah, that is, it was Wednesday. It was Wednesday. It was Wednesday when the highest temperature was recorded. Find the difference between the temperatures recorded on Tuesday and Friday. The word difference referred to as the answer you get after subtracting. I told you in the previous lesson that sum is the answer you get after adding. So the answer we get after subtracting is difference. So what's the difference between the temperatures recorded on Tuesday and Friday? So which one is the biggest? When was it? So that is Tuesday. Tuesday had 39. Remember the units are degrees centigrade. And then take away. So Friday has 38. So we shall say minus 38 degrees centigrade. We use our ruler and we underline. Always use a ruler when you are underlining. So we shall first put the degrees, the units here, degrees centigrade. 9 take away 8. Good, that is 1. Because 1 plus 8 we get back 9. And 3 take away 3. The answer is 0. So the difference between the temperatures recorded on Tuesday and Friday, the difference is 1 degree centigrade. So today we are looking at time. I know everyone has a clock face around in your sitting room. Time is measured in units of, we have 1 seconds, minutes, and hours. Those are the units that we use when we are telling time or measuring time. Time, we use 2 units here, or 2 points when we are telling time. You can tell time in AM or PM. What does AM mean? It means ante-meridian. And then PM means post-meridian. Others say meridian, but it's not. So ante-meridian means time after midnight. And then PM means the time just after midday. So this one, AM can mean time before midday, or after midnight and then before midday. And then PM after midday and before midnight. So PM, we use PM, the time when it's afternoon and then evening. That's why I put here afternoon and evening. Just going back a bit, AM is used for time from midnight to the time 1 minute to midday. And now, like here, we have our clock face like the one I'm having. When it's in 12, when all the hands, we have a second hand, we have a minute hand, and then the hour hand. When they are all pointing here and it's in the night, this one means it's midnight. This one means it's midnight. No minute, no second has gone past. So it is 12 AM, that is 12 midnight. And now when it gets to, like here, when it comes to there, when the hour hand is in 1, like this one, and then the minute hand is pointing in 12, it means that is the hour. So that one is 1 hour after midnight, when it's in the night, is the same as 1 o'clock, or 1 AM, or 1:00 AM. This one means that no minute has gone past 1 in the night. So this is 1 AM in the night. So we are still telling time in AM. When we get to PM, we shall see how that one can be also. So how about when this minute hand is in 12 and the hour hand is in 4? It is 4 hours after midnight. This one means that fraction, that part of the day, the first half, we've so far moved the 4 hours. Remember, a day has 24 hours. So the first half is from midnight to midday, and then another half is from midday to midnight. And now this one is the same as 4 o'clock in the night, or 4 AM, or 4:00 AM. It means that no minute has gone past 4 AM in the night. So this one is 4 AM. It means that those are 4 hours past midnight. Now, you look at this clock face which is here, and this one simply means is midday. If it is daytime and you find that your clock face is behaving in this way, the minute hand and hour hand or even the second hand they are all in 12, it means that is midday. So if it's like this, we say it is 12 hours after noon, or it is 12 noon, or we can say 12:00 p.m. This is the time we even start saying good afternoon. So we start saying good afternoon at 12 sharp, or when it's 12 noon, at times we say 12 noon, others want to ignore at 1 p.m. and just say it is 12 noon. It is the mid of the day. That's why we say midday. And then if we are tell time in p.m., I told you that time in p.m. that is from midday and then up to 1 minute to midnight. So 1 hour after midday is 1 o'clock or 1 p.m. Normally if we are at school, that's the time we go for lunch. That's the time we go for lunch, and it's like this. When the time the clock face is showing this one, everyone becomes happy because it is 1 p.m. 1 p.m. that's the time we go normally for lunch, and that is 1:00 p.m. No minute has gone past 1 in the day, daytime. If it is 8, like in our number 2, if it's 8 and no minute has gone past, and that is evening time, 8 hours after midday, we say it is 8 o'clock or 8 p.m. 8:00 p.m. evening time. That is evening or night time. Normally, if we are at school, that is time when we are ending our prep time. If we are home, that's the time when we are normally going to have our dinner and then we go to bed. So 8 hours after midday is 8 o'clock or 8 p.m. Back here, if it was 8 hours after midnight, it would be 8 a.m. After midnight, it would be 8 a.m. But this is 8 hours after midday, and it is 8 o'clock or 8 p.m. or we can write it as 8:00 p.m. Putting those two ratios, or we type, or at times we call them dots, that is evening time or night time. So, if you are telling time and you have a clock face like mine, or you have a digital watch is normally show this, and the clock faces like this one with the hands, minute hand, hour hand, and second hand, they normally show time like this one. If it's a digital watch, like a wristwatch on your hand, it will be having such. Now, we go to this one here, more about telling time. And you see these small dots. Those are the minutes. From one dot to another, that's 1 minute. From another dot to another, that's 1 minute. If you have to count from 12 here, it will be 1, 2, 3, 4, 5, until we see that one where we have 1. Those are 5 minutes. So here, we count the 5 minutes. Here we shall have 1, 2, 3, 4, 5. And then we shall say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. And then here, we shall not say 60. Why? Because 1 hour has 60 minutes. We are just going to say that's the top of the hour. Now, here I wrote here half. At times when we say, we don't say 30, it is 30 minutes past, or it is 12:30, at times we say it's a half past. So we have an example here. Tell the morning time on the clock faces below. Morning. Remember I told you previously that the morning, if you tell time in morning, we use AM. If it's morning, we use AM. That's the time from midnight to 1 minute to midday. So now here, this is morning time. What shall we write? Is it 3 yet? No, it's not yet 3. What's the time? It is just coming to 3. If it's just coming to 3, meaning the time is still 2. So we shall say it is 2. And then how many minutes have gone past 2? We shall start from 12 here and we say 5, 10, 15, 20, and 25. Why are we counting in 5s? Because from one number to another, there are 5 minutes. So we are counting in fives. So now here these are 25 minutes. So we are going to say it is 2:25. But what are we going to put here? We don't need to put here o'clock. Because when you put o'clock, it is not going to specify whether it is evening or it is morning or afternoon. So we come back to our question is, tell the morning time. And morning will match with AM. And that one, you'll get your tick. Even this one here, it is morning time. So, where is the minute hand? The minute hand is pointing 9. And then the hour hand is just coming to 1, meaning it is still 12. So what are we going to write here? It is still 12, so it is 12. We put the ratios, the dots, and then we count these minutes and say 5, 10, 15, 20, 25, 30, 35, 40, 45. So shall put here 45. And now, what is it? It's morning time. So we are going to put N, and that is our morning time. If you have a dictator watch, the time the dictator watch puts 12:45 a.m., that is in the night. Those are 45 minutes past midnight. Now, we come here telling the time, tell the afternoon time or evening time on the clock faces below. This is now afternoon or evening. This one will match with PM. So now, on our clock face that we have here, it is, what's the time? The hour hand is like showing as if it's between 6 and 7, but it's not. It is still here. So it has just gone past 6, meaning, and we move clockwise, we move in that manner. So we shall say it is still 6. And then how many minutes have gone past 6? It is, let's go, 5, 10, 15, 20. So we shall say it is 6:20. Now what are we going to write here? Is it AM? No. Why? Because it's afternoon or evening. We are going to use PM. So it is 6:20 PM. Which time is this? That is evening time. When we have gone away from school, so we are home, we are going to have our supper and then play bit. Now, we have another clock face here. The question is, tell the afternoon stroke evening time on the clock face. So here, is it afternoon or evening? Which time of the day is this? We see that our hand is almost as if it's between 1 and 2, but it's not. So it is coming to 2, meaning it is still 1, it has not yet reached 2. So when you look at our clock face that I'm having here, let's see. Yeah, exactly. So it's not yet 2, but there are some minutes which are remaining for it to get to 2. Meaning we shall say it is still 1. If it is still 1, how many minutes have gone past 1? We are going to say it is, I told you we start from 12 and say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So this is 55. We shall come and say it is 1:55, but it is afternoon. So which time of the day is this? This is the time when we are almost going to class, or it's still lunch time and we are still playing and we are soon reaching the time we're supposed to go to class. So this is, we can say morning time we use AM, and afternoon stroke evening time we use PM. Good. So we go to telling time on the 12-hour clock face, or the 12-hour clock. So if we have been given show 3:45 PM, the clock face may not be having the PM there and the AM, but if you've been given you've been given here the show 3:45 PM, meaning it is not yet 4, it is 3. So the most important thing is for you to know is where will the minute and the hour hand be. So if it is 3:45, let's first get the minutes here. We shall count and say 5, 10, 15, 20, 25, 30, 35, 40, 45. So the minute hand is going to come here. It will point in 9 exactly. But it is not yet 4, so we are going to say it is 3:45, meaning 3 some minutes. So we shall dot and say it is here. So that is 3:45 p.m. So this is the time when we are soon ending our lessons. 3:45 when it's almost coming to 4. The moment this one moves and it reaches 12, the hour hand will automatically be in 4. So this time here is on my clock face. It will be showing like this. This is 3:45. When it moves and it reaches when the minute hand reaches 12, it will be exactly in 4. But right now it is still 3, and we shall read that one at 3:45 p.m. Now this is example 2. Show 8:05 a.m. on the clock face below. So this is our clock face, and this is 8:05. That's 5 minutes past 8. So I told you we have to count from 12, and we count 5 minutes. These dots that you are seeing there, those are the minutes. So we count 5, and the minute hand will point in 1. So we are going to say this is 5. That is 5 past 8. Now 8 here, it will not be in the middle of 9 and 8, but it will just be slightly there. Remember, the hour hand should be shorter than the minute hand. So this is 8:05 a.m. This time is now morning time. So look at number 3. Show 9:20 p.m. This is night time, but according to our clock face, it will not show whether it is morning or afternoon or night time. So this is 9:20. So 20 minutes past 9. We are going to show and say 5, 10, 15, 20. So our minute hand will come and point in 4 there to show 20 minutes. And then 9. It will not be between 10 and 9, but it will be slightly after 9. So that is 9:20 p.m. on the clock face. But I told you, we don't have AM here on the clock face, and we don't have PM. We only have the degrees and the minutes, so and the hands here. We just need to look at this, and so which time of the day is it? Is it daytime, afternoon time, evening? And then we use the AM and then PM. AM, this is PM. So we have number 4, example number 4. Draw a clock face and show 9 p.m. So our clock face is here. So we show 12, 6 here, 3, 9, 10, 11. This is 1, 2, 4, 5, 7, 8. So 9 a.m. 9 p.m. So the minute hand will be exactly in 12. So this is exactly 9 p.m. This is night time. So that is the top of the hour. No minute has gone past. So that's why we put the 00 there. So the minute hand will be in 12. That's why we have the 00 minutes. We have example part B of showing 6:15 a.m. So we shall have our 12, 6, 3, 9, 10, 11, 1, 2, 4, 5, 7, 8. That's our center of the hands. So 15 minutes. We shall have first of all to look at the minutes. So we shall say 5, 10, 15. So the minute hand will have come and point in 3. 6 is here. But because there are some minutes that have gone off 6, we shall say Now like here, right now it is 6 o'clock. If it's now 5 minutes, 10 minutes, and 15, you see it has gone slightly after 6. It is somehow there. So I'll draw the hour hand and put it. Remember, the hour hand should be shorter than the minute hand, as you can see my clock face here. So when you are drawing the clock faces, remember to position these digits properly, and then also the hands, the minute hand should be longer than the hour hand, or the hour hand should be shorter than the minute hand. So that's basically on how to tell time in AM and PM. Now, let's look at how we change time from hours to minutes. Changing time from hours to minutes. We have to know that 1 hour is equivalent or is equal to 60 minutes. When this minute hand moves, let's say it is 6 o'clock. If it moves round, until again it gets back to the starting point, it has moved 60 minutes. It has moved 60 minutes. So we have an example here. Convert the following hours to minutes. 3 hours. If someone tells that the activity lasted for 3 hours, how many minutes were there? We shall say 1 hour is equal to 60 minutes. How about 3 hours? We shall say 3 hours will equal to 3. We draw a line here, and this very 3 we write it here, and this one which is up there we bring it here. Then we multiply by what is there. So this is times 60, and this side we put minutes. Now 3 divided by 1 is 3, and then 3 times 60, that's 180. Then we put minutes. So 3 hours are equivalent to, or are equal to 180 minutes. If not so, you can simply say that 1 hour, since 1 hour is equal to 60 minutes, another 1 hour, 60 minutes, another 1 hour, 60 minutes, then we can add. These are 3 hours, and then we can say this is 0, and 6 plus 6 is 12, 12 plus 6, that's 18. So you just simply say 3 hours are equivalent to 180 minutes. But now, shall we continue adding like this? What if we've been given 40 hours? So here will be the easiest way of how to deal with changing hours to minutes if the number is really very big. Let's look at example B. Changing 2 hours and 20 minutes to minutes. Changing 2 hours and 20 minutes to minutes. We have a solution here. 1 hour is equal to 60 minutes. How about 2 hours? Let's first deal with 2 hours, and then these other minutes we shall just add on the minutes that I need. 2 hours. So 2 hours, we shall draw this line here. This very number, we bring it here. 2, then out of this one, we bring it down, then times 60 minutes. So 2 out of 1 is the same as 2, and 2 times 6 is 12, and then we bring the 0 there. Or 2 times 60 is 120, or 60 plus 60 is 120. And then those are 20 minutes, and then we bring the other 20 minutes and we add here. So we say 0 plus 0, 0, and 2 plus 2, we get 4, and then 1 plus 0 here is a 1. So in 2 hours and 20 minutes, there are 140 minutes. Okay, so let's look at example number C. We have changing 1.5 hours to minutes. Changing 1.5 hours to minutes. Solution. 1 hour is equal to 60 minutes. How about 1.5 hours? First of all, we have to convert this fraction. This is a mixed fraction. So we shall say 2 times 1 is 2, and then 2 plus 1 is 3. 3 out of 2. So 1.5 is the same as 3 out of 2. So we have 3 out of 2 hours equivalent to 3 out of 2 times 60. So we shall say by 2, 1. So then 6 divided by 2 is 3, and 0 divided by 2 is 0. So we have 3 times 30. So we shall say that 3 times 3 is 9, and there's a 0 there. Or 3 times 30 is 90 minutes. Or 3 times 3 groups of 30, that is 3 groups of 30. So 30, 30, 30. When you put them together, you will get 90. So that is 1.5 hours will give us 90 minutes. So when we are changing from hours to minutes, that's why we have to multiply by 60. Why? Because 1 hour has 60 minutes. Now, let's look at how about changing from now minutes to hours. Changing time from minutes to hours. Let's look at the example number 1 here. Change 120 minutes to hours. We have our solution. This time we are going to say, because we are changing minutes to hours, we shall put minutes on our left and then hours on our right. Just like you have put it here. Minutes and then this side hours. So we shall say 60 minutes are equal to 1 hour. How about 120 minutes? You can't put here hours, then here minutes. No. We have to make sure that they are on the same side. So we are going to say, I've told you, we draw this line, and then this number which is here, we write it here. And then what is up, you drive it down and write it down there, and then times what is there. Times 1 in bracket hours. This side is for minutes, and this side is for hours. So 120 times 1 is 120 out of 60 in bracket hours. So the 0 and the 0. We remain with 12 divided by 6, it will be 2. So this one means that 120 minutes are equivalent to 2 hours. Remember to cancel here. When you cancel 0 and the 0, you remain with 12. 12 out of 6 means 12 divided by 6. And that one gives you 2. So those are the 2 hours that will give us 120 minutes. Let's now look at example 2. It rained. This one is, it rained for 90 minutes. Express the minutes as hours. So we shall still say 60 minutes can give us 1 hour. How about 90 minutes? I told you, when we write, we draw a line. We draw a line here, and this very number, we write it here. And this one here, we drive it here, and then we multiply by what is up there. So we shall say the 0 and the 0 will give us nothing there. So 9 divided by 6 will be here, and then we reduce. We divide both sides by 3, and then 9 divided by 3 will give us 3. 6 divided by 3 will give us a 2. And then 3 out of 2 is the same as 3 out of 3 is the same as 3 divided by 2. If you have 3 apples and you have 2 girls, everyone will get 1, 2, 3. So everyone will get 1 full apple, and then the other 1 apple that will be remaining, you partition it and give each one a portion, and everyone will get a half. So 3 out of 2 is the same as 1, and 1 out of 2 hours. And therefore this one means that 90 minutes are equivalent to 1 hour and a half hours. So this is basically how we can change time from minutes to hours. Now, let's look at another sub-lesson, which is duration. Duration, that is a period or length of time an activity has taken when it's taking place. Or the time that you take doing something, that is, we refer to it as duration. Now, duration is ending time minus starting time. If you want to know the time you've taken while doing something or performing an activity, just get the time you started and the time you ended doing it, then ending time minus starting time, you'll get the duration. The time between is what we refer to as duration. Ending time and then this is starting time. So ending time and starting time, you get what we call duration. And duration is measured in hours, minutes, and so on. Now, examples. Number 1, a lesson started at 8 a.m. This was, remember, this is morning time. And ended at 10:30 a.m. Still morning time. How long did it take? So we shall say duration is ending time minus starting time. Now, when you are writing here, put here hours and minutes, because I told you duration is measured in hours, minutes, and seconds. So when you put hours and minutes, don't put AM. These ones are not needed here. You shouldn't include them. So just forget all about that. So now we come and look at this, minutes and hours. We subtract from the side of minutes. But we first will look at the minutes which are up here. If they are bigger than the minutes which are down, we shall subtract normally. But if they are smaller or less than the minutes which are down, we shall have to regroup 1 hour and bring it the side of minutes. Remember, 1 hour is equivalent to 60 minutes. We shall look at that in the next example. So here, the minutes which are up and the minutes which are down. What is the difference? No difference. So we shall say 30 is bigger than 0. So we are going to subtract normally. So we shall say 0 take away 0 is 0. And 3 take away 0 is 3. So now we have 10 hours, take away 8. We shall say 0 minus 8. It's not easy. We come here, we leave there 0, and we bring the 1 there. So that is 10 take away 8. We shall have a 2. So meaning we shall have 2 hours and 30 minutes. So this lesson that started at 8 a.m. and ended at 10:30 a.m. lasted for 2 hours and 30 minutes. So let's now look at this example here. An assembly that ended, the assembly ended at 9:20 a.m. had started at 8:30 a.m. How long did it take? Remember, duration is ending time minus starting time. So we shall have hours and minutes. I told you, don't bring AM here. Don't bring AM here when you are finding duration, or PM. I told that first look at these minutes. If they are less than the minutes which are down, you have to do something. But if they are bigger, like in our first example, just subtract normal. But now 20 and 30, meaning 20 is less than 30. So we have to do something. Because we can't say 0 minus 0, 0. But now 2 minus 3. Don't bring here 1 and put here, and then it will be 12 minus 3. That will give you, good, that will give you 9. Which is, we can't write here 90 minutes. The smallest number that can appear under minutes is 00, and the biggest number that can appear under minutes is 59, not 60, not 97, and so on. So these minutes which are down here are less than the minutes which are down. So we are going to say we shall come to neighbor under the clan of hours. We shall tell him, give us 1 hour. And when he gives us 1 hour, he will remain with 8 hours. But that 1 hour, we don't just bring one like this. No, we don't do that. So what do we do? That 1 hour, when that 1 hour comes the side of minutes, the clan of minutes will be minutes now, which will be 60. So we are going to say 60 plus 20, or 20 plus 60. We shall say 20 plus 60 will give us 0. This is 8. 80 minutes. Now the 80 minutes take away the 30 minutes. So 0 take away 0, 0. And 8 take away 3 is 5. So we shall write here 0, 5. And then 8 take away 8 is 0. So this assembly lasted for 0 hours and 50 minutes. And that is now simple. You have to say it lasted for 50 minutes. Okay, now let's look at distance, time, and speed. So we shall start with distance. Distance is the measure of length between 2 points or places. Like you can be given what's the distance between Jinja and Kampala. That is distance between the two places or 2 points. The distance between this board from the starting point, the other side, when you measure that one is also distance. Distance can be measured in kilometers, meters, and so many other units, so long as meters are there. Now, there is a triangle here that I put here, so we are going to look at it carefully. Now, at home, we have so many decoders. And out of these decoders, I know one, we have star times. We have Azam. What else do we have? Good. We have DSTV. We have which one? Okay. So let's we have GoTV and so many others. Among these ones here, which one is so good? Which one is the best? Yes. So we have DSTV. It's very good, very expensive, and in mathematics, we are going to apply it here. So DSTV, we are going to take only the first 3 letters, D, S, T. And now D is standing for distance, S is speed, and T is time. Now, if we say that we are looking at distance, first of all, distance equals to speed times time. Distance equals to speed times time. And distance, I told you the units, kilometers, meters for this case. That's where we are going to end. And we have an example here. A motorist took 2 hours to cover a distance at a speed of 70 kilometers. To cover a distance at a speed of 70 kilometers. So, here we are going to look at calculate the distance the motorist covered. Calculate the distance covered by the motorist. Calculate the distance covered by the motorist. So, we are going to draw our triangle there, and we should always remember the DSTV. So we put here DST, and we shade the D because we are calculating distance. Now, distance equals to speed. Here's a multiplication sign, and we say speed times time. So the speed is 70 kilometers per hour, and the time is 2 hours. But 70 kilometers per hour is the same as 70 kilometers out of 1 hour. This one means that every 1 hour, that this motorist was covering 70 kilometers. Every 1 hour was covering 70 kilometers. So we want to know the distance he or she covered in that duration of 2 hours. So we are just going to say 70 kilometers per hour times 2 hours. Because the formula for finding distance is speed times time. So it's 70 kilometers out of 1 hour times 2 hours. So the hour and the hours will disappear, and then we remain with 70 kilometers times 2, which will give us 140. So the distance covered by this motorist was 140 kilometers. Now, let's look at number 2, calculate the distance covered by a cyclist traveling at a speed of 60 kilometers per hour for 1.5 hours. You see there's a fraction there, so we should be very careful. So our triangle normally, we shall say DSTV. Remember the formula? We shade the D, and we say distance equals to speed times time. Our distance for this number is 60 kilometers. I mean the speed is 60 kilometers per hour times 1.5 hours. But now this 1.5 is a mixed fraction. So we have to change it to an improper fraction. 2 times 1 is 2, plus 1 is 3 out of 2. Then we shall have the 1 hour out, and then we cross it out. So we shall have 60 times 3 out of 2. We say by 2, 1. 6 divided by 2 is 3, and 0 divided by 2 is 0. So we have 30 times 3, that will give us 90 in brackets kilometers. So the distance this cyclist covered was 90 kilometers. If you just say in 1 hour this person is covering 60 kilometers, how about half an hour? Half an hour it will be 30. So when you add 30 plus 60, you get to 90 kilometers. Even in our example number 1, if every 1 hour, this person was covering 70 kilometers. Another 1 hour, 70 kilometers. So when you add these 2 hours together, you will find that the distance covered is 70 plus 70, which is 140 kilometers. So that's how we calculate distance when given speed and time. Now, let's look at how we find speed. Our triangle will come here, the DSTV, and we shall say DSTV. And we shall now come and shade speed. And now D is up and down is T. So because of this bar here, we shall say speed equals to distance out of time. Distance out of time. Distance divided by time. And what are the units of speed? We have kilometers per hour, or we have meters per second. So this one shows us how many kilometers does someone or a moving body take to cover in 1 hour. Or how many meters does a moving body cover in a second. Let's look at this example here. Kiprotich covered a distance of 21 kilometers in 3 hours. Work out his speed. Work out the speed that Kiprotich was using. Solution. So the speed, we should know, we shouldn't forget DSTV. So we calculate, we share the speed here and say speed equals to distance out of time. Distance out of time, which is 21 kilometers out of 3 hours. Now, 21 divided by 3 is 7 kilometers per hour. This one means that every 1 hour, Kiprotich was covering 7 kilometers. Now, if there were 3 hours, if we have to check ourselves and see if our answer is right, 1 hour, 1 hour, 1 hour. Every hour, 7 kilometers. If you add here, there will be 3 hours. If you add here, there will be 21 kilometers. So the speed is very correct. 7 kilometers per hour. When you look at number 2, a boy covered a distance of 90 meters. This time, they are not kilometers. They are meters. In 40 seconds. What was his speed? A boy covered a distance of 90 meters in 40 seconds. What was his speed? Look here. Still, if we are to draw a triangle, remember the formula DSTV. So we share the speed and set distance out of time. The formula we have to apply in finding speed. So the distance given is 90 meters. And then the time given is 40 seconds. So it's 90 meters out of 40 seconds. So the 0 and the 0, that's divided by 10. So 0 will go with the 0. We remain with 9 out of 4. And 9 up was given to 4 girls. Everyone will get 2 and then a quarter. So the speed was 2¼ meters per second. That is 2¼ meters per second. So this boy here was covering 2¼ meters every second. Wow, it was very fast. Now let's say how we find time, because we have seen how to find distance, how to find speed, and then we are remaining with time. So now we draw a triangle again, put DSTV, and then we shade time. So time is distance out of speed. Have an example here. Work out the time needed to cover a distance of 400 kilometers at a speed of 90 kilometers per hour. Solution. We need to find the time, so we shall come and show the time. Distance out of speed is distance out of speed. So the distance given is 400 kilometers, and the time, the speed is 40 kilometers per hour. We need to find the time. So 400 kilometers out of 90 kilometers per hour. So the kilometer will go with the kilometer, 0 and 0. We shall remain with 40 out of 9, in brackets, hours. So what is 40 divided by 9? The answer is 4, whole number. That is 4 times 9 is 36. And 40, take away 36, the remainder is 4. Then you maintain the denominator. So the time here needed to cover a distance of 400 kilometers when the speed is 90 kilometers per hour is 4 hours, and then 4 out of 9 hours. So we should always remember the DSTV, that the formula finding distance is speed times time, and then the units of distance are either kilometers, meters, and others. And then speed, kilometers per hour, meters per second, and then when you come to time is either hours, minutes, and then seconds. So we should always remember this formula when we come across speed, any question having distance, speed, and time. Thank you so much for watching.